for using ultrasonic fraud detector CTS-976 produced by Siui. Siui has been dedicated to R&D, manufacture and sales of ultrasonic fraud detector for more than 30 years. We are specialized in medical ultrasound imaging systems, ultrasonic testing equipment, and ultrasonic transducers. As a perfect combination of various advanced technologies, CTS-976 has many outstanding features: small size, multi-purpose, low consumption, high performance, easy operation, lightweight. Moreover, the CTS-976 has many superior features. It has 80 to 2000 Hz PRF with 10 steps adjustable. It can avoid reverberation signals during fraud detection. The AVG DGS curve can make 3 curves of different equivalent values with one node flat bottom holes or large bottom echo. The AGC function with peak echo and image freeze function can help you quickly identify the floor highest echo. The peak memory function facilitates quick scanning and measurement on workpieces. Functions like AWS, API, and TCG are optional. Besides, it has weld group profile function. Up to 300 sets of curve and waveform can be saved for various workpieces and fraud detection standards. The DAC curve works with echo compare function, makes echo quantification of different distance and amplitude more convenient. What's more, the system supports up to 9 kinds of language. In order to make you understand features of CTS-976 and operate it expertly, we take bar wells inspection as an example. In this inspection, we use CTS-976, AFN2 1010-60L angle probe, V1 test block, CSK3A test block, and 20 mm thick steel plate. First of all, in order to let you have a better understanding, we would like to introduce the key functions. There are several keys: direction, confirm, main menu, function, and power keys. Each key has its own function. Direction keys are to select submenu, adjust values, and switch items. Confirm key is to execute a function or confirm an item. Main menu keys include basic, DAC, AVG, calibration, storage, and configure functions. Basic key is to adjust basic parameters, including range, velocity, delay, zero, reject, gain, step, gate start, gate width, and gate trash. Correction key is for auto calibration. Here we would like to introduce the operation procedure. Step 1 is calibrating velocity and probe 0. Step 2 is measuring probe angle. Step 3 is making DAC curves. Step 4 is testing welding line. Step 1. Calibrate velocity and probe 0 on V1 test block. Firstly, set system parameters to default. Press Configure key continuously until to default submenu is shown. Press direction keys to move cursors to default, and press direction keys to turn off to on. When sure is shown in the screen, press Confirm key and then Completed is shown in the screen. Press Correction key to go to Correction main menu. Select the submenu reference 1 to 100 mm and submenu reference 2 to 200 mm. Set aspect to 250 mm. Select the submenu option and set it velocity and 0. Put the probe on V1 test block aligned with the R100R surface. Move the probe at the central position of the testing surface. Make sure the probe parallel to the edge of the testing block to ensure the south spin axis perpendicular to R100 mm curved surface. Find the peak of the echo by moving the probe. By using peak envelope function of F1 key to find the peak of the echo. Hold on the probe and use the ruler to measure the distance m between the probe flank to the top of R, and the probe flank distance, L0 is 100 minus m. Input the probe flank distance, L0 in the Configure main menu. Hold on the probe and adjust gauge start position to hit the echo corresponding to R100R. Press AGC key to bring the echo amplitude around 80%, and then press Confirm key. The screen prompts, "Please record echo for reference to." Adjust gauge start position to hit the second echo of an R100R. Press AGC key to bring the echo amplitude around 80%. And then press Confirm key. The screen prompts completed. Now the display velocity and 0 are the current material velocity and probe 0. Press Correction key and select the submenu Angle Measure. Press Confirm key to go to the submenu of Angle Measure. Select the submenu Hole Depth and adjust the hole depth to 30 mm. Select the submenu Hole Diameter and adjust the hole diameter to 50 mm. The probe should be aligned with the 550 mm hole. Move the probe back and forth to search the highest reflection hole echo amplitude of 550 mm hole. Pay attention to make the probe parallel to the edge of the test block. Hold the probe when the highest reflection echo is found. Adjust gauge start position to hit the echo, and press AGC key to bring the echo amplitude around 80%. Press Confirm key and the measured angle will be displayed in the submenu Angle. Making DAC curves on CSK3A test block. Press DAC key to go to DAC main menu. Select submenu DAC operation and adjust it to record. Use Calibrate Angle Probe to find the 10 mm depth Phi 1 shaft drill hole in the test block. Pay attention to make the probe parallel to the edge of the test block. Find the highest reflection echo corresponding to the Phi 1 hole. Adjust gauge start position to hit this echo. Press AGC key to bring the echo amplitude around 80%. Press Confirm key and the first echo reference point is recorded and the first curve section is drawn. Repeat steps above and record echoes of the holes with depths at 20 mm, 30 mm and 40 mm. After recording the required echo reference points, a group of DAC curves are completed. Set the submenu thickness in Configure main menu based on the thickness of the workpiece to be tested. The steel plate we are testing now is 20 mm. Set the coordinate mode to depth. We use zigzag way to test spot welds on the steel plate. When testing butt welds on steel plate, the probe is usually near the butt welds and then most of ultrasound beam go through the steel plate. Therefore, not all the refraction echo signals on the screen are floor echoes in the butt welds. If those non-defect echo is misjudged as defects, it will cause quality evaluation error, even unnecessary butt welds rework. Accordingly, we need to determine these refraction echo signals. The position of the refraction point is the main consideration for determining whether the refraction echoes are for defects or not. Therefore, in the butt welds testing, first of all, we need to make sure the position of refraction echo and determine whether the refraction point is in the butt welds. Let's make this step by step. Move the probe back and forth at both sides of butt welds to get the highest echo, and adjust again to hit the highest echo. Use the highest refraction echo horizontal distance LF and depth position D to determine whether it is defect. Method is as follows. Determine the horizontal distance LF between the refraction point and the incidence point. Use the ruler to measure the distance L between the probe flank and the weld edge when at highest echo amplitude and the butt weld width A. If L is less than LF, LF is less than L plus A, the refraction point is in the butt welds. If used the first echo, the distance between the refraction point and the steel plate surface is less than the steel plate thickness. It can be considered as defect refraction. If used the second echo, it is necessary to analyze the distance between the refraction point and the steel plate surface, weld group type, and then judge whether it is defect refraction. If LF is less than L, or LF is greater than L plus A, and the refraction point of the highest refraction echo is not in the butt welds, which is normally not welding defect. After finding defect in the butt welds testing, it is necessary to determine the defect depth position, the distance between defect and weld center and defect size based on the defect highest refraction echo in the time baseline position. When the refraction echo is determined as defect, move the probe back and forth at both sides of the butt welds to get the highest echo of the defect, and adjust again to hit the highest echo. Pay attention that the highest refraction echo on the screen cannot be too high. If it is out of screen, press AGC key to make the peak of the highest refraction echo on the screen becomes visible. Read the defect depth D and size, the relative position of the defect highest refraction echo peak and the DAC curve on the screen in order to determine the defect wave height area. Read the horizontal distance between the probe flank and the defect LF is 25 mm, and use the ruler to measure the probe flank distance 26 mm, and then the distance between the defect and weld center is 26 minus 25 is 1 mm. And then use the ruler to measure the distance S3 between the probe center and the test block left edge, for example, 126 mm. Different standards have different measurement methods for defect indication length. Take standard JBT 4730 as an example. If the defect echo is in zone 2 with only one peak amplitude, we can use 6 dB method to measure indication length. Move the probe at both sides of the butt welds to get the highest echo, and adjust again to hit the highest echo. Press AGC key to bring the echo amplitude around 80%. Move the probe to the left and bring the echo amplitude around 40%, and then hold on the probe and use the ruler to measure distance S1 between the probe center and the test block left edge, for example, 120 mm. Move the probe to the left and bring the echo amplitude around 40%. At this time, Measure the distance S2 between the probe center and the test block left edge, for example, 132 mm. The defect indication length is S2 minus S1 is 132 minus 120 is 12 mm. That's the end of the operation procedure. Thank you for watching and have a good day.